Part 2, the composition of the lithosphere. Today we're going to discuss rocks. Rocks are solid materials made of one or more minerals. Minerals that make up rocks determine the properties of that rock. There are 3 classifications or categories of rocks, and we categorize them on how they formed: the igneous, sedimentary, and metamorphic rocks. We call the change from one form of rock to another the rock cycle, and it's an important aspect of earth science, the rock cycle. You can see the rock cycle is very cool. James Hutton is considered the father of modern biology, and in the 18th century he developed the concept of the rock cycle, and he also developed the thought of a vast geologic time. So during the first segment of this class, geology, we're going to be referring to Hutton quite a bit. This is an illustration of the rock cycle. We will start with igneous rock. Igneous rock can undergo weathering and erosion, which would break it to sediments. Those sediments could be deposited and then cemented, and that would form sedimentary rock. Igneous rocks formed by the solidification of magma or lava. Metamorphic rocks formed by heat and or pressure. So one rock can form into another type of rock when it's exposed to heat, pressure, or weathering and erosion with cementation or lithification. So rocks are always changing, and the rock cycle describes how these changes take place. Igneous rocks, which are our first type of rock, are formed by volcanic activity when magma, and magma is under the surface of the earth, or lava, which is at or above, literally in the air, solidifies. So when magma cools, it takes millions of years for the magma to cool because it's inside the earth. The term is intrusive. The crystals get very large, so it's called coarse-grained texture. When lava or ejecta cools, it cools quickly, and that's called extrusive or exterior of the earth. It has a fine or glassy texture. So the texture of the rock is determined by where it forms. We use that texture, coarse, fine, glassy, or fragmental, as one of the ways to identify rocks. The other characteristic we looked at is the color tone, the overall color tone. A light colored rock is termed felsic. It tends to contain a lot of quartz. A dark colored rock is called mafic. That tends to have a lot of metals. Intermediate rocks can have both. And then the ultramafic rock is very rare. So we look at texture and color tone. The longer a rock takes to cool, the larger the crystals. The faster it cools, the smaller the crystals. On the left, you can see crystals, rather large grained, cooled slowly. The center image is basalt. It's dark colored and very fine crystalled. The last, obsidian, is glassy, no crystals. So you are moving from cooling slowly, cooling fast, to immediate cooling, and you can tell that by the texture. Basalt, upper left, fine-grained. Coarse-grained, in the middle, is granite. Glassy, obsidian. And then the porphyra, the fragmental, is below, showing a basalt fragmental. Those are the textures: fine, coarse, glassy, fragmental. Pyroclastic means ejecta, means forms in the air. It has some air bubbles, so it's glassy with air bubbles. You can see the two distinct volcano types there. The explosive volcano with the pyroclastic ejecta above. The basaltic volcano below, which is Hawaii, with the lava. Those are continental. Continental is the explosive. It tends to be granitic. And the nice flowing tends to be basaltic, and they are oceanic in origin. So the light-colored felsic magma tends to be granitic. It has a lot of silica. It comes from explosive volcanoes. The dark-colored rocks, the mafic rocks, tend to be rich in metals, and they come from oceanic-type volcanoes. Incidentally, the ocean crust is made mostly of basalt and basaltic-type rocks. The continental crust is made mostly of granite and granitic-type rocks. So we'll start off with the light-colored rocks, light-colored felsic rocks, continental in origin. They're called granitic rocks. Granite is a type of granitic rock with large grains. Rhyolite is a type of granitic rock with fine grains. So one forms deep in the earth, one forms at the surface, same chemical composition, both felsic igneous rocks. Intermediate tends to have a mix of the colors. They would occur on continental margins. They're often called andesitic rocks. Mafic rocks, I've also heard it called mafic, so if you're hearing something, I pronounce it mafic, but I've heard it called mafic. Dark colored, because they contain metals, they have a higher specific gravity, less silica. They form the oceanic rocks, the basalt and gabbro images there, same concept, fine-grained, coarse-grained, same material, dark mafic minerals. And then ultramafic or ultramafic rocks, rare, olivine, that we discussed in the minerals, Hawaiian in origin. So when identifying the igneous rock, you would choose texture, glassy, fine, coarse, very coarse. You would see if it had gas pockets or not, vesicular versus non-vesicular. You would look at the color scheme, which would be lighter, darker. And then using that, you would use the chart to see, for instance, coarse rocks could be granite, diorite, gabbro, peridotite, and dunite. Light would be granite. Intermediate would be diorite. Darker, gabbro. So you use this like a matrix to find the type of rocks. Then once you get the type of rocks, you can look at the mineral composition using the chart below. Using the cursor, if I circle granite with the cursor and move down, You can see it contains potassium feldspar, pink to white, so granite can be pink to white. Contains quartz, head off clearer crystals, plagioclase, biotite, amphibole. So those are the common rock building minerals found in granite, rhyolite, pumice. So using this chart and observation, you can determine the igneous rock type and its composition. The next type of rock is the sedimentary rock. Most of the Earth's surface is sedimentary rock. Sediments are cemented together. They're generally associated with water, weathering and erosion, and then cementation, but not always. And they preserve a record of the environments where they form, including fossils. This Wentworth scale, sand, silt, clay are the most common sediments, but you can get pebbles and cobbles and boulders. Those are the loose materials that make up sedimentary rock. We classify them by size. The three major types of sedimentary rock are clastic or detrital, broken pieces of rock cemented together, organic, shells cemented together, coral reef, and then crystalline or chemical evaporites. Like limestone can be an evaporite, dolostone can be an evaporite, calcite evaporates in water, so they are commonly calcite or dolomite. Easy way to test for that is the fizz test with hydrochloric acid. So here's some clastic or detrital rocks. You can see conglomerates, just a hodgepodge glued together. Siltstone is silt-sized particles. Sandstone is sand cemented together. Shale is rock, mud and clay cemented together. And breccia is that porphyry. Organic sediment rocks, coal is common in the plants, or the coquina fossiliferous limestone glued together. And evaporites. Gypsum we use for plaster, salt, chert is silica glued together, and then limestone, chemical limestone. Fossils can be found in sedimentary rocks. So if a sedimentary rock has, if a rock has a fossil, it is a sedimentary rock for sure. This chart is how we identify them. Whether they're clastic, pieces of rocks cemented together, conglomerate, breccia, sandstone, siltstone, or shale, depending on what's glued together. Whether they are chemically or fossiliferous. You use those observations to determine the name of the rock. Metamorphic is a changed rock. It's been exposed to heat, pressure, chemicals. It takes an igneous rock, squeezing it, changing its structure, metamorphosizing. Sedimentary rock, squeezing it, changing its structure, metamorphosizing it. So heat is the number one agent of metamorphism, causes the recrystallization. Pressure is the second metamorphic agent. It changes the specific gravity. Chemicals can play a role. Chemicals can metamorphosize rocks. So if plate tectonics cause regional metamorphism, which is entire areas are metamorphosized, Mountains are formed, folded mountain belts, for instance, due to tectonic pressures. Contact metamorphism occurs when lava or chemicals come in contact with very specific rocks, and you don't have an entire area metamorphosized, but localized metamorphism. Foliations tend to occur when you have muscovite or biotite, micas, hornblends, feldspars. Granites tend to foliate. They form layers when they are metamorphosized. Precipitates tend to, like quartzite or marble, which they tend to non-foliate. Slate comes from the metamorphism of shale. Schist and gneiss are metamorphic rocks as well. They're shiny, they contain mica, and they form bands. Calcite, when it metamorphosizes, forms marble, no bands, and quartzite comes from quartz. Marble comes from calcite. Slate, you can see the bands in the slate. Schist is real shiny because of the mica. Gneiss is very, very banded. Schist is squeezed. It turns gneiss over time. It's called schistose texture because it's shiny, very shiny rocks. Banded as well, foliated. So there's some foliations in that image. More foliations, schistose quality, very glittery, if you will, shiny. And then the last one is banded but not very shiny. There's still foliation, so that is not a schistose banding. Non-foliated rocks are the marble. Marble comes from limestone. It will effervesce, easy test. Quartzite. Quartzite comes from heavily quartz-containing granites. And then anthracite coal comes from squeezing bituminous or sedimentary coal. That's that so-called clean coal with quotes, clean coal, because most of the impurities have metamorphosized out, so it releases less pollution, still releases a fair amount of carbon dioxide. So clean coal is still harmful for the environment. There's no such thing as clean coal, but it's termed clean coal because it burns purer than bituminous coal. The scheme for identification, once again, another chart, foliated rocks up top, looking at their general shininess, and non-foliated rocks below. Really, the coal's easy. The quartzite will not bubble, and the marble will bubble. So that's how we identify the metamorphic rocks.